Okay guys, in this lecture we're going to discuss what are binary systems, and in that we're going to discuss four subcategories. First is why do we use binary. Second will be the conversion of binary integers to decimal and vice versa. Third will be what a byte is and how it's used in the memory sizing. And the fourth one will be the use of binary in computer systems and related technologies. Now we know that computer is a machine, and that machine can only recognize two types of input. First is a high voltage and second is no voltage, which looks something like this. Now this can be represented as a 0, a high voltage will be a 1, 0, 1 followed by two zeros, and this piece of information can be collectively represented as 0100, which is a binary number. Now moving on, one of the very important concepts that you need to learn is conversion of a binary number into its decimal equivalent and vice versa. So we're going to start off with that. We're going to take a sample binary number. In this case it will be this number right here on your screen. Now in order to convert a binary number into into its decimal equivalent, we use the positioning method. Now what the positioning method is, it means that every character in the binary sequence has a certain position, and each of those positions have a certain weight or power to them. Now in order to express that, I'm going to show an example. In this number right here, we write the number clearly with some spaces so we can work well with it. You can see we have 8 characters in our number. We start off by writing powers of 2 starting from the right side in an ascending order. We write 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, till 2 raised to the power 7, or however long the number goes. Now what we do is we take the numbers that have a 1 on top of them and we start writing it like this. Plus we take the next number with a 1 on top of it, we write that, and we add all the numbers that have a 1 on top of them, and then we evaluate it. Further evaluation. Now adding these, we get 147. That is your binary, and that is your decimal number equivalent to the binary number that you just converted. Don't forget to write the base under a number to make it clear which number system it belongs to. Now we're going to do a reverse conversion of the number 147 into a binary number. Now when we do this, it will also help us to confirm whether our previous conversion was correct, because if we get the same number as this one, it will mean that our conversion was correct. Now how we go about converting a decimal number into binary is simple. We write the number 147, then we start dividing it with the base of the binary, because we want to convert it into binary, which is 2. So we start dividing it. We will only do integer division, which means there will be no decimals involved. So first of all, we have 147 divided by 2, which gives us 73 with the remainder. Now we divide this again, which gives us 36 with the remainder 1, dividing again. Now what we're going to do is we're going to pick all these remainders and we're going to write them down one by one in the direction denoted by the arrow. Oh, sorry, my bad. Now if you look at it closely, you will see that it is the same as the number we obtained earlier. Like, these are absolutely the same, which confirms that our conversion was perfect. Congratulations, now you know how to convert a decimal integer into binary and vice versa. Moving on, we are going to discuss what a byte is. A byte is basically the smallest unit of memory that a computer can process. A byte consists of 8 bits. Like, any combination of 8 bits that you can write will be called a byte. 1 1 1 1 0 0 0 0. This is a byte because it has 8 bits. Now, a collection of 4 bits is called a nibble. You can remember this for short questions in your exam. As byte is a unit of memory and it is quite small, we have some larger units of memory which are as follows. So yes, 1024 bytes equal to a kilobyte or a KB. 1024 equal to kilobyte equal to a megabyte or MB. 1024 megabytes equal to a gigabyte or GB, and 1024 GB equal to a terabyte or TB. These are powers of 2 as explained here. Now moving on, as we have already expressed the use of byte in the memory, we're going to talk about the use of bytes and binary number systems in a computer in registers or other units of memory. First of all, a computer uses bytes because of a transistor. Now what a transistor is, it is a simple switch that can either be on or off. Now please ignore my exceptionally made transistor. Now an on state is expressed as a 1 and an off state is expressed as a 0. Now what happens in a register is, a register is something like 8 or 16 transistors combined. You can call this probably a resistor. Like, how many we've got? 1 2 2 2 3 4 5 6 7 8. Now we have well, let's call this register A. R dot A, register A. Now register A has 1 transistor can either be in an on or off state, representing a 1 or 0 in its position. So yeah, this is it for now, and you finally know all you need to know about binary systems. You can probably do good in your exams after this video. Thank you so much for watching. Now before we go, let's revise just a little bit of what we have studied up till now. So we saw why we use binary number systems, then we converted a binary number into decimal and then converted that back into a binary number. Then we saw what a byte is and what are the units of memory and how the memory is measured. We followed that with what a transistor is, and in the end we saw how transistors are used in combination to form a register that is a unit of memory close to the CPU, which is used for high-speed processing. Okay, thank you so much for watching. Please subscribe and press the like button. Thank you very much.